Well, I am. We'll get to that part in a second. First part is this.
So it seems like it took 5 minutes until I could log into the machine the first time from when I tried to create the instance. So that's and then I can kick off the script. So we'll see how long the script takes.
Okay. So
there we go.
Are you sharing through Zoom, Jay? Or?
Yes,
yes.
He's sharing through Zoom right now. Let's call this. Hold on to that. Get rid of that. All right. I think we're set up for streaming, which we already are. So there we are. It's a little bit less prepared than normal today. We also, sorry, I'm also trying to tweet while I'm talking, which is horrible. We're going to do the tutorial today for the peanut butter and jelly. You already ran the already ran the script. You already started the script.
Script is running.
Script is running now, but while it takes a bit of time. Have I got that correct?
Yep.
So while it's going, we're going to start with Jay just always being the typer and rotate the three of you through as talkers. You want to grab the timer, Jay? And do we have the Dependabot set up on the tutorial project?
I think the answer is yes, but it doesn't have CI, so I think we have to manually push it along.
Push it. So, all right, when we bring it in, let's just make sure that we're on the latest version of pipelines.
Okay. We have it pushed a new package since February.
That is disturbing.
We'll get
There
to
has
it.
been
It's
a
on
bit
our
of,
to-do
like, it
list.
feels like something might have happened in the world in February that has thrown us off kilter. Nothing comes to mind.
I think we're okay. Tutorial will still work.
All right,
The only thing that's really new is the ping.
PNG graphics, and we don't need to use that for this. Although,
It's okay. I mean, we'll get the gist of the. I think the important thing is to understand why refactoring pipelines.
yes, fair enough. Ooh, Jay, we could do it just as an image reporter. Like, we could just make a reporter that gets the dot file, gets the other dot file, turns them both into temporary images, and launches a diff reporter.
Somebody write that down.
Writing it down.
I want to talk. So one way to approach learning a thing is to do it once without understanding it, and then once you've done it, go back and have the higher level conversation about what you just did. And the other is to talk abstractly about the concepts and then try to apply them. And both are frustrating because they're not the other one. But one of the things that I think I do want to say to the group before we actually start doing anything with code is if you think about this is a function call, and we know that you can take any expression or statement and put it into a lambda.
Yeah, this is the extract or encapsulate lambda concept.
Yeah, and this isn't quite legal C#. And then call it. And that is, in general, in most languages, a behavior preserving transformation.
It's only not legal because you don't have a semicolon, you can't use var. So change your var to a funct of peanut butter. What does get available give you back?
Peanut butters, there we go.
Peanut butters. Now it's legal.
Yeah. Right. So it's a little bit annoying that we're not in Haskell, I guess, where you have to write down the types for these things. But
yeah, but the easier way to do what you just did is, so undo that. So like what was it, Jim Work? First, like I first saw this really nicely in Jim Work's Ruby. Jim is dead now, but he was a great speaker and teacher. So what you would do is just go to line 11, and he would do this in JavaScript like this all the time. And in front of it, put the lambda.
Here?
Yeah. And then right before the parentheses, put the parentheses.
Yeah.
Now, because it's C#, you're going to need to, put parentheses here. No, just parentheses there. And you don't even have to do that, I think. I think you just need a parenthesis there.
Yeah, I don't think so. I think you have to cast this.
A funct of peanut butters.
We're almost there. More parens. A little more. There we go.
Oh, you don't need it out of. Oh, no, you do because of casting. Yeah. So, and then extract. And you don't have type information in JavaScript, so you could just do the function boo boo. And that encapsulate lambda. That is a remarkably useful refactoring that is hardly ever talked about.
Mm-hmm.
Right? Because so if you just think of normal, David was referring to this as CVA. It was like constant variable assessment. I always think of this as the duplication coloring book, but whenever there's the thing that is different isn't a value, but a procedure, this encapsulate lambda is how you extract that. Like, so like, if you are just doing duplication and one thing works with 5 and the other thing works with 10, you extract a variable called number, right? And everybody understands that. But the things that is different is one thing calls print and the other thing calls display. The idea that you extract a function pointer and that's your variable, somehow that is really much more complicated for humans to grasp. And that's why like a lot of programmers don't write higher order functions, right? Is because just somehow there's like a mental block, even though the coloring book is exactly the same. So this function is how you take the thing that is changing and extract it as a variable. When the thing that's changing isn't a number, but is a method or is a procedure. It's super useful function. So
Super useful transformation.
Transformation, yeah.
Yeah. Okay, so I hope everybody is feeling good about the transformation that we just did. If you're feeling lost now, we're going to be in trouble in a moment. Just want to check in.
I'm familiar with the concept of lambdas, Python has them too.
Yeah.
I'm a bit confused by all the parens.
Yeah.
But the concept.
So once you get into here, we can take away all those parens.
So like this highlighted part is the lambda.
Yeah.
But because C# was not built as a functional language, you have to.
Maybe can you put the refactor and put the variable?
Yeah. So if you click on var right now and make it explicit, then all of this goes away.
Mm-hmm.
And now it's much
Is that what you're
simpler, I
thinking?
think.
Yeah. So that sequence that we did, like there was an annoying manual part where we added a bunch of parens and a cast and an arrow. And after that, everything else is automated refactoring to get us to here. And this program still does the same thing.
Yeah, so honestly, like, I really wish there was an automated refactoring in ReSharper to
I know.
introduce Lambda. Like that, it wouldn't even be hard to program. I don't understand why it doesn't exist. But I think the way we use ReSharper and the way the people who develop ReSharper intend us to use ReSharper are not in sync.
Yeah. So can we try something? Can we go back and try refactoring?
Yeah.
I know something, but I never tried it.
Ooh.
So select the whole. Yeah. Select
That much or that much.
Try extract method.
Extract local
method.
So extract method. Local function. Try.
Nice thinking.
Okay.
Yeah. No, this is good. Now, Nix, you have to convert that.
Yes. I
So
don't know
click
if
on-
there's a refactoring.
No, there is. Click on peanut butters and quick fix. What are your options?
You go to expression body.
To expression body, yep.
Yeah, so this is still not a lambda, it's a local function.
Yes.
So
However,
close.
now add an equals.
Okay.
It's not enough, no, because it's the func.
And in front of it, put func.
Yeah,
It's the minimum, though, you have to do.
yeah.
Right? Like, it's more than the minimum. It's always the same. Right? You will always be putting func in the front of it, and you will always be adding an equal sign. It won't be type dependent. It won't be. It's always the same. You could write a macro to do that.
Yeah.
That was good. Thanks, Valentin.
Yeah, that's really good.
I always get the, so who, like when I get that option, who needs a local method? See, this is the first time I actually correct the local method.
I like local methods. Okay, so like they're really nice if they capture a variable. So you're showing us that we can do this transformation, but I don't think you explained why this is relevant.
Oh, no, yeah, I've got more. This is only step one. All right, so
So maybe it is related or maybe not. Well, why is it, let's say, the difference between a local method and a lambda relevant here? Say you use them in the same way. I know lambdas as anonymous functions that I can feed make an inline function as a parameter to in a function call to something else. That's how I'm used to work with lambdas.
The difference isn't important yet. It will become important in the next step.
Yeah, I'm not even entirely sure if that's true.
And the reason it's important is that this is now data.
But it was data the other way too. I mean, technically these are the same thing.
So this is
It's
a
also
function that
data.
happens to be declared in an inner scope.
No,
Really?
I'm pretty sure that that's a lambda. Inner functions are lambdas because they do variable capture at the method
We
level,
do capture,
which means that you
Amazing.
know
Okay.
that the IL has to be the same.
yeah. Okay, I want to set this question aside because I want to move on with this, and then we'll come back to it. That's it.
Yeah, but the important part is to conceptualize that this is data, and I think that's easier to do in a lambda, regardless of how the IL looks.
Yeah. So if you have a piece of data, a variable, we can put it in a class. So I'm going to come over here in class, and we're going to put this in it. I hope I do this right. I feel like I'm going to make a mistake here, and it's not going to make sense.
Yeah, because now you're not capturing the
Yep.
you're not capturing
This
it
is-
correctly.
This is on purpose, I think. I don't know. You're going to have to correct me in a moment.
All right.
All right. That returns a peanut butters, and I'm going to make a function called do.
Sure.
It's going to take the code. I'm going to put this in here for now, and then down here I'm going to make
Func doesn't take a zip code parameter.
you're right.
Yeah. No, and yeah.
But do does.
There, we're back to green. So we're saying we took this local variable, it's just data, and we put it in a new class. And now I want to make this a field. Can I do that? Introduce field.
Mm-hmm. Local capture makes it complicated.
It does.
You can do that, yeah.
But we're getting closer. All right, let's make this thing generic.
Generic for what it takes or generic for what it gives?
Both.
Yeah. Okay, so what he just did is a very interesting way of making this generic, which I am conflicted about. But if you rename the
It's
zip
not
code,
quite
will it do what
valid.
you want?
Yeah. So that was a breaking. That doesn't actually work, but it's useful. And all this one's T input, and this one's T output.
That is an
And
interesting
this
way of
one
refactoring that.
input. And an important missing piece here. This func needs to go from T input. Is that what was missing? No.
So I think we did know the lambda should have taken a parameter, not the zip code as a parameter. You want to do capture or
Yeah.
not?
You need to capture.
Okay.
No, so because so this one is
Yeah.
saying yeah.
No, wait, do you want to capture or not capture?
Yeah. Let's back up to a clean state and
But
try it
where are
again.
you trying to go, Jay?
I'm trying to get to the point where there's an object. I guess what I want is I want to pass in this lambda as a constructor parameter next.
All right. In that case, let's just go straight to there.
Sure.
So right now you're capturing it, right? This compiles?
Yep.
So
What
now,
does that mean? Capture? Is it a closure? Something else?
It's a closure that is capturing zip code.
yeah.
Okay.
So now let's do a lambda or a constructor that does this.
And it's going to take one of these. Do that again. Write a constructor. This statement into the constructor. You can't do that.
No, you don't want to do that. You want to pass in the funct of peanut butter.
Okay. So we're going to move this statement.
No, you're going
out
to
of
keep that
view.
statement exactly where it is.
Okay.
You're just going to pass it into the constructor on 29. And you're going to capture, like, modify your constructor here and capture a result. So right now we're capturing it early and then we're reassigning it. And then we're deleting that line. And now you can modify to not pass zip code since we no longer care about the zip code.
Let's pause there for just a moment and check that everybody's okay with that last step.
All we've done is encapsulate. We just added a layer of indirection.
Yep. You don't need that.
You should have used refactoring for deleting unused parameter.
That'd also be nice.
Alt delete? Yeah. There you go.
All we've done right now is added an entire layer of indirection. Right? We've made this code
Yep.
significantly more complicated to do exactly the same thing. And we are going to work on how to do that today. Because the nice thing about indirection is it allows you to layer things in. Right? But I'm not sure that this is you did this on the idea of like you started this, but sometimes we do something without understanding the bigger picture. So I want to give you the bigger picture first. I'm not sure we've
Yeah.
achieved that.
Yeah, I think that's fair. Okay, let me try to talk about the bigger picture a little bit. J is now an object that will run a function that you give it.
Yeah.
That's the concept. So before we had a statement that does a thing, now we have an object that does the same thing. So we've made a transition from a series of statements to, well, in this case, one so far, one object that represents the statement that used to be there. And once you have objects, you can start doing things with them in code.
Which you can't do to statements.
Yeah.
Like for example, here we could put a toString on the object, right? Or we could put like a guard check on the object. Or like we could put a modifier on the function. You can do things to objects that you transforms that you cannot do to just statements. There's no way to say, give me all the lines of code in this method and let me put a log statement in between them. But if all our lines of code in the method just became objects, then we just have a list of procedures and you could do things in between the list. Does that make sense?
All right, I want to do one more thing here, and then I think we're done with this approach. We do the real thing, which I'm going to rename this to function. This object is an object that represents a function. Which is, I don't know, I feel like that's an idea that is a brain twister to people who have never tried to write like compilers. Maybe, I don't know who the audience is, but that's what this is. And you could call this execute or invoke or something. All right, anyway, I feel like we're done with this unless somebody else has another question, and then we should switch to the other activity.
Yeah, so I'm kind of still getting a little bit confused. So yeah, I mean, I can see that if it gives us a way to basically inject a layer of interaction into the code. But this one doing it purely on functional level.
Yes. Well, not functional. These are all objects. I mean, let's not pretend that IL is a functional language, right? What it is these are classes, right?
Yeah.
And these are classes that contain classes, just to even make it like more complicated. But it is a level of indirection. It's taking something that did just exist at the IL and giving you the ability to interact and manipulate it and display it and query it and do all sorts of things that you can't do with the innards of a method.
But then what happens if those methods require internal state?
They do.
So can we still do this function?
Zip code is internal state.
Oh, but what if, let's say the peanut shop is not a static method, but it's just a method, and that get available actually using some state inside the peanut butter shop.
Yep, it literally happens on line 31. Not going to be a problem. Because that's what zip code is also not static. It's a local variable, right?
Yeah.
So this is actually capturing that.
Okay.
Well, instead of a static method, you have an instance method. Before that, you have a class instance. You create a new object, no? And on that, what you pass in the function is that new object dot some method, no? So it's capturing this object that has so even if it's an instance method, it's the same.
Yeah, so I guess the reason why I'm asking all the questions, I'm still getting a little bit confused. How come this become a little bit helpful? I know we're getting somewhere, but I'm not kind of clear on the big picture yet.
Yeah, I think the tutorial will help with this.
Yeah.
What's the status of the script, Jay?
The Visual Studio stall failed. So
Failed?
the machine is, with an error. I don't know why yet, so I'm running it again.
From Chocolatey?
Yep.
Wow. All right, I'll run it again. Let's start this up. Timer. I think you might be okay. Yeah. Oh wait, hold on. Go back. Is this the new one?
Yeah.
Should we put in a break?
Not that new.
Not that
Not 2, not 3.
All right.
But we can still wait.
Oh, if you're gonna do that, it's easier to bring in the break. But we only have 3. How about we do a break every second rotation? So what I'm gonna have you do is gonna be super weird. Add Robert again, and Valentine and Tony, and then put a break. There we go. I feel like that's a good cadence. So we are
Jay,
starting here.
Always the typer.
Jay's always going to be the typer.
Yeah.
So I'm gonna do a little bit of navigating the Navigator. So Robert, there is actually instructions for how to do this on our website. Can you get Jay to open those up?
Yes, I'm delegating that to Jay.
Not the exercise, the actual pipelines. Probably should put a link to that in here.
Refactoring to async. Oh.
Yep, so start doing that, Robert.
So let's read this until we understand sufficient for doing some stuff. Have we done the prep, Jay? So.
Yep.
Yeah.
Did we import the NuGet, the pipeline NuGet?
Yep.
Okay.
Okay. So I have a challenge to match the code on the right with the text in the tutorial. I'm not sure if that is
Would it be easier if
expected to be self-explanatory.
copy the comments in the template without the original code? Because that's the original code. Or,
Well,
So-
no,
so the-
paste it
okay.
at the top.
Then, yeah.
Say it again, well,
Paste it at the top.
okay, yeah, please do.
So these are the things you need to do, and the original code is that.
The original code is what we have on the right.
Exactly.
Okay.
Now do step number 1.
That's a question from the test. So let's add a test then.
There's a test here.
Mm-hmm.
I call it.
Oh, it's already done, no?
Yep, it's already there. So you
Okay.
can run this and see that it does something. Particularly what it does here is it passes.
Mm-hmm. Okay.
Next.
So now we can start refactoring. So step 2 says take the first thing to move to async and create an input pipe of its parameters directly above it. I'm not entirely sure if I understand this, but please do step 2 then, Jay. Okay. So then we proceed with step 3, place approvals tests to get insight into the pipeline. Let's also do step 3.
So it seems like the test is failing. Yeah.
Okay. And let's run the test.
Something.
That doesn't look good.
Enter. So this is the dot file. We need to. You have to preview it. Okay. Okay.
So what is that telling you right now?
It's the input.
Good. And are you expecting the input to be zip code?
Yes.
Good. Keep going.
Okay. Let's approve it.
You don't have
Or
to
no.
prove it yet, because we haven't yet
Yes.
finished the whole thing, and approving means nothing at this point.
Okay. Let's go to step 5. So we did step 4. We inspected the result on test code. Okay.
In step 3, it didn't say though that we had to run the test, so I thought it made sense. What else is there to inspect in step 4 with them?
That is a good point, though. We should do that.
So after the starting point input, put that the method call pipe and peanut butter. This process function instead of process. Okay. Now we need to add a collector. So we do the verify. Should we check again in VS Code how it looks like? Let's do that.
I'm a bit confused that the tutorial says the method call, but we're not pasting in the method call, we're only pasting the method.
Yeah. So say it again, Robert.
Can you go back to Visual Studio?
So it looks good to me.
Yeah.
Okay.
On line 15, we're only passing in the get available methods. And
Yes.
the tutorial says we should pass in the method call.
So how would you say?
So why
so we're
would we
doing the
not-
right thing. How would we say it correctly? So what I'm hearing from you is what we're saying and what is happening is not lining up for you. Right? Like it feels
That's
like it's
confusing,
telling you to
yeah.
do something else. I totally accept and agree with that. However, what he did is the right thing. So my question, the thing I want to change is how would you express that?
Well, if we did the right thing, then I think we should change the tutorial and
Yes.
change the code to the method instead of the method call.
And
Oh,
pass-
so it's confusing that it has a call itself. Okay.
Yes.
Do you want to do the editing now or?
No, I'll do it.
Okay.
I wasn't sure what to say.
Okay.
Would it
So-
be clear if we said like a pointer to the method?
Mm-hmm. Yeah.
All right.
Or the method. Yeah.
Say the method instead of the call. Is that the?
It's the method instead of the method call. This is very good feedback, Robert, because I might be biased because I know a little bit about the project, so.
Mhm.
But yeah, okay.
Sure. So it looks to me that so we have the method pipe, so which means that our next step we have the verify. So do we need to approve it now, or we can go to the next step? Okay, so
What's
Sorry.
the next step? Go ahead and do the next step.
okay. So then we have a method collector, which is a method called pipe.collect. So let's do that. Should it be before the verify or after the verify?
Before.
Before. So then, based on my impression so far, essentially what we're saying is the input pipe, the input will be zip code. The input will passing in a process function, and then we have a method called pipe, which will collect whatever that process function return. So which means that we have a method called relections, method called collector. So then if we want to execute the entire pipeline, then the next step would be starting point of send. and then we're passing in the first parameter, which is a zip code.
What line do you want them to be at?
Should be right after line 16, right? So basically starting point of send, and then we got the passing in the zip code in there. Right after that, we have the variable, which we say method collector dot single result, which is we try to get the result back to the variable. Yeah.
Just a small feedback. I noticed that the input, in the tutorial we start with starting point input, and then we change to starting point in the point 6. The point 6, so that's a small thing to change.
Yeah, I wonder if the names for the tutorial and the name in the doc and in the code should line up.
That would make sense.
Can we? Here would be another check on to run the test. No, because I would like to see the resulting. I think this is some feedback that I notice right now. So it's a little confusing because you pass to the verify, you pass an input point, but in a way it's the whole graph. So I don't know if we should have a concept of the entire graph in a way, because you verify an input point, but you actually verify the graph. No?
You're verifying the graph, yes. I'm not sure I'm understanding what you're suggesting.
Okay. Can we just see the? Can we draw this dot file? Okay.
So we don't currently have an object that represents the graph as a whole. We have objects that represent the nodes, and then you can pick any node or almost any node and say draw the graph that this node is a part of.
Yeah.
But it's not currently something that represents the graph as a whole. And maybe that's missing.
Yeah, because conceptually saying you're passing a node, but you're operating on the entire graph, it's kind of confusing when you do that. Because I would expect, say, for example, verify the entire graph. This is one to verify, not a single node.
Yeah, but you are right. Like, we also don't have, that concept doesn't exist in our code.
Yeah.
It exists in the output.
Because what if you have multiple inputs and you get confused, what should I pass in there? As you said, it doesn't actually matter because it's the whole graph.
Yep. That's
But
the idea.
So could we pass in any node in the graph, and you still get the entire graph as output?
Yeah.
Okay.
go back to disable.
So does this graph look like as we expected? It seems to make sense to me, but I don't fully understand it yet. It seems to make sense.
Okay. Good. Keep going through the process. Like, there is one problem. So what do the comments say? Just read the comments out loud for me.
So set a pipeline.
Yep.
That we do. A brutal pipeline.
Yep.
And then send through pipeline. That send is out of place.
Yes.
So should we then move the code down after the verify?
Yeah, and that's actually important. Let's show you why. Can you go to the test? I'm not sure if this actually works, but we have implementation log. Can we do implementation error? Run that now.
Want this back up above?
Yep. Okay, so now it never gets to the verify. Like, running this code will explode. Right? So it never gets to the verify, so you can't see anything. And very often, you will have code, especially code that calls services and stuff like that, that you can't actually get through. but you want to be able to refactor it, even though you can't execute it at the moment. And the advantage to this is by putting it after the verify, you get to see what the code would do if you execute it, and then it blows up. Or specifically, it blows up at the verify, so it never even gets to the point where it would blow up.
You would have to, just to make sure I understand, you want to build the graph first, then verify it, and then send things.
Bingo.
Okay.
Well, why does it blow up?
Because whenever you call get peanut butter, it throws a service not authenticated correctly exception.
So you kind of inject an error.
Yeah.
But isn't that the purpose of this? Is to make the refactoring simple. So then, why do we need the verify step?
Because you need to make sure that you are actually creating the graph the way you want it to.
So my impression is that the verify step is only applicable when we write tests for it.
It is useful when doing this refactoring.
Okay.
Because otherwise you're doing a lot of refactoring with no feedback.
True, yeah. For this specific tutorial, it is useful because we do it kind of a step by step.
When I'm doing this in legacy code, it is useful. It's more useful.
So if you look ahead a little bit, you'll see number 11 is actually move the verify call into a unit test. So after you do the refactoring, you actually get rid of, you move it into a unit test.
Oh, okay, I see. Okay,
but we want feedback that we've done the right thing. And you will not get that unless you put the calls after. Like, once we turn on this logging, you will never see the graph if you put the send through pipeline before the verify.
True. Yep. Okay, thanks.
Okay.
So let's go back to the code. Okay, let's move the that after the approval pipeline. Okay, now let's do the same thing. Let's rename the input pipe to zip code input, or what do you guys think would be a good name? Okay, let's put zip code input. Okay, and put a name there, like the method called pipe. Can you make it more, maybe like get available in a butter shop? I'm not sure. It's kind of too long.
So usually we call the pipe based on what it gets back. Or is it what goes into it?
I think this is get peanut butters.
Get peanut butters. Okay.
But it should include the word pipe. Peanut butter's pipe.
Okay. Yeah.
So a bit confused that we are doing a verify, which sounds like a test to me.
Yeah.
But we're doing it outside the test code. So
Yes.
what are we doing in this function where it seems we're doing two things? We're testing the pipeline, and then also sending input into the pipeline to execute the function.
Yeah, although we never get there because
Usually
the
we
test
call the
breaks.
pipe based on what it
What
gets
just
back.
happened? Oh,
Or is it what goes into it?
I think this
I'm
is
trying to see the
get
chat.
peanut butters.
Get peanut butters. Okay.
sorry, I'm doing this completely wrong.
But it should include the word pipe.
I was trying to get the Twitch chat, and somehow I got the Twitch playing again, and then we had to lose that. Sorry about all that.
So, Robert, you were saying, why do we do the verify in here? If I
Yeah,
understand.
because Well, my understanding is that it's actually a test to verify.
Yes.
But we're doing a test in
Uh,
our main code and not in our test functions.
Exactly.
temporary.
And that's what's confusing me.
Yeah. It is
Because you
temporary.
cannot run this code yet,
Okay.
right?
We're
Because the
moving-
moment
we're
you
moving the
try
verify
to
to-
call peanut butter shop get available, this code will blow up.
Mm.
So you cannot run it. So we need to put the test in the middle of here as a temporary shunt.
Okay. So let's do the same with the jelly shop. So do
Hard to pull off.
the same input. Can we reuse inputs, or do we have to create another input pipe? Can input pipes be reused?
Use it again.
Yeah.
So let's create
No,
Yeah.
there's no more input. Oh, yeah, there is. Yeah, you can use it again. Sorry.
okay. So let's create another pipe for the jelly shop.
There was a missing step
There's a
here,
missing step here.
because we're supposed to take this result and use it. Process and collect the next step in the pipeline, delete and remove. Yeah, there's something that needs to happen here, which is we've collected this variable.
No, it's
type
the
peanut
end
butters.
of line 6. So that it isn't var variable. It's var peanut butters equals peanut butter pipe dot single result.
Oh, this-
Or you have method call collector, but it should be peanut butter collector dot.
Yeah, let me do what I did again, because that was an important missing step. So right here, I'll turn green. There we go.
Can we rename those pipes though? Just call that peanut butter pipe.
You want to rename pipe that has its name.
Okay, but then rename the collector to get peanut butter's collector.
Why do we want line 15 and 16? Because I thought they are kind of duplicate. We already have a process function. Why do we want to get the pipe to collect it?
Because we're putting stuff into the pipe, we're not taking anything out of the pipe.
So then what is the purpose of line 16 then?
Line 16 is to get something out of the pipe.
Tony, just to again, if you look at the point 8 in the tutorial,
Yeah.
you previously used collect to pull out values from intermediate step, but as becomes you can delete them. So so this is just for these are intermediate steps. And your
Okay.
scalar,
So then when we say we delete any newly deadly code, then right now I don't see any newly dead code though.
Yeah, there is no newly dead code.
Yeah. We
So-
could rename that variable into some kind of like peanut butters result or some kind of peanut butters.
No, the whole idea is to. Can you move line 22 down one line? So the line we're trying to transform is line 25, right?
Yeah. So then they are duplicate now. So I
Yeah.
think we can. So a couple of ways we can do it. We can copy and paste line 23, anything after the equal sign, and paste it over the anything after the equal sign on line 25.
Exactly.
Yeah. Yeah, and then I guess delete that line too, yeah. Yeah, so that whatever we did, we basically replaced that.
We have replaced that one line that we had on 24 with these 1, 2, 3, 4, 5, 6 lines.
Yes.
Yay, refactoring.
Okay, so then which means that we can continue doing the next one is the jellies, is that correct?
Exactly.
Okay.
Say that again?
Was that break, Jay?
So
Are
we're
you
just
fast
starting
forwarding
right
people? Oh no. Okay.
Okay, so my turn and we get a break. Okay.
Yeah.
So then if we continue doing that, then follow from step number 1 again, where we try to set up the pipeline. And then, so the first thing we do is we probably declare var, I would say var jelly.
Okay, wait, hold on. Let me give you
ahead.
alternative instructions, and we need to change the actual instructions to match this. So,
Okay.
copy the line you want to transform. What line do you want to transform?
25.
25. Okay, copy that. Paste it to the bottom of your setup pipelines.
Okay.
Then you have to ask the question: the input parameters, is there already a pipe that gives you the input parameters?
No. We need to create a new input
There is.
pipe.
What is your input parameter?
Oh yeah, you're right. The input is the same, so line 14 is the same.
So then you
So
put
which
that at the front of the method, and you use the pipe.
Put that as the front of the method when we use a pipe. So which means we have the zip input, zip code input.
Yeah.
Yeah, and then we tie another process function,
Exactly.
and then so which means that we have another. So zip code input is essentially.
And then the thing that
Okay.
comes out of it, you have to add the word pipe to.
Yes, so which means we have a jelly pipe.
Good.
So which means on line 17 we need to rename that to a jelly pipe.
The next
And
thing you have to
then-
do is collect it.
Okay. Then we type jelly's pipe dot collect. Okay. Now which means that the pipeline approval will approve it for us.
So wait, hold on. So then you have to ask if you created a new pipe, a new input. Did you?
No, we're using the same
So then
input.
we don't have to send anything else through. So
Yeah.
then we take the collector and use it to instantiate the variable of the line we're trying to replace.
Collector to instantiate. Okay, so which means that on line 27 we can just dot basically jelly collector down single result to get what we need.
And now confirm that you've set up your pipeline correctly.
So which means we do the verify. Okay, so things starting to make a little bit more sense
Like
now.
that flow. Yeah, which I don't think we're
Nah.
explaining well in the doc.
Yeah. The only thing that I find still confusing is if we have an input type dot process function, why do we still have to do the collect? Which I find it odd.
Because putting stuff through the pipe doesn't hold on to it.
Putting stuff into the pipe doesn't hold on to. But then from a client perspective, do I really care? Because if I'm the one that using the pipeline stuff, all I care is I specify the input, I specify whatever that
You need
function
some way to
or
set
the-
that variable on line 17.
in some way set by on line 17.
Yeah. Or
Okay.
whatever. Can you take us back to that code, Jay?
All of that.
So, on line 27, you need some way to set jellies. Does that make sense? Oh, you're muted.
Sorry. I think that's part. I think that's fair. Right, there's gotta be a way for us to get the result out.
Yeah.
But the part where
But the
I'm
pipe will
getting-
not give it to you. The pipe gives it to whatever's next in the pipe.
yes,
It doesn't hold on to the result. It has no memory.
it has no memory.
The collector has memory.
maybe I'm not sure if it will be an improvement, make it easier. Maybe you can collect directly from a pipe. I'm not sure that would be correct.
Yeah.
Yeah, and we actually don't want that.
And I'm also confused that we first call the collect and then we send something in the pipe.
Collect
I would
is
expect.
it's building a collector. It's maybe the method name collect is confusing. My understanding is
Yeah.
it builds a collector.
Exactly.
Hooks a collector. Yeah. I don't know.
Okay.
Even
So
the
then,
process.
okay, so now it's kind of starting to get a hang of this. So basically, really, the first thing we want to do is we definitely need to have the input. So there's no choice.
Yeah.
But then we must give people a way to specify the input. That is definitely. The second thing is we want a way so that we say, hey, here's all of the processing function, or here's all of the handling or processing or whatever it is that we can all of them in a collections. And then finally we say, okay, we say hit run or hit execute to give us the result back. So yeah, that collector, I feels like there's some extra step that we don't have to do
It
because
is,
like
but you need to do it at this moment.
So it's only temporary because the collectors help you to get the value back. But once you build more of the graph, they will not be needed.
I see. So the collector is basically just giving us back the result for that specific process
Exactly.
function. But if we have a multiple collectors, then we have a different way to get all of the collectors together.
Usually you only
Yeah,
want one collector in the end.
Yeah.
Right? Because methods only return one thing.
Okay, methods only return one thing.
But we
Yeah,
don't.
methods should return one thing.
Yeah. But right now we are getting multiple things out because we need them. Right? Like right now, this pipe needs to return us peanut butters and jellies.
Okay.
We are in the middle of the refactoring of the methods, so we need those intermediate values for now.
Yes. So then another question then, how does this one tie to the async call?
Oh, hold off on that one.
Okay.
It's a totally good question, but just hold off.
I was about to ask that. Well, is it then right to say that on line 23 the send is executed synchronously?
Right now, it is executed synchronously. Yes.
Okay, so then that's why a single result can be an attribute and not a method that gets called and
No,
a feature.
actually, even if it was asynchronous, you could still get single result. So single result is just saying, I expect one thing to have gone through this pipe. Give me the one thing that did.
Mm-hmm. But if it would be executed asynchronously, the pipe might have not executed yet. So a single result might not be resolvable.
Let's go, I have some feedback about that, the asynchronous part, but let's finish the tutorial. Let's transfer it asynchronous, and then we'll have some discussion. Because you actually have a very good point. I filed an issue on the pipelines GitHub, and we can discuss about it.
Okay.
Alright. Time for a break, eh?
Yeah, I think it is. You want to pull up the break timer, Jay?
How long are we waiting for?
The 4 minutes.
Okay.
Yeah, there you go. All right, see you in 4. Jay, how is the EC2? Did it crash again? Oh no, you're gone. All right. Do the next line, Robert.
Okay. So we have the peanut butters and jellies, and line 28 we can leave as is, I think.
No. That's the next line.
Okay, so refactor that.
Yep.
Can you show that entire line? What are we doing here? Okay. So we want to make a so now we have to wrap that sandwich.create in the pipeline, correct?
Exactly. And it's a pipeline. How many inputs do you have?
2.
Okay, so the first thing is, you can't just move a single input to the front of this. You're going to have to combine these two inputs. So what are your 2 pipes?
The 2 pipes are on line 15 and 16. Sorry, 15 and 17.
Good. So there's a function called combine that will combine them.
Okay. So can we refactor line 15 to get peanut butter's pipe to peanut butter's pipe? To make it consistent with line 17, and the same for line 16. Also remove the get. Yep. So then we can now say combine. How do we call it combine?
Dot combine.
Going to.
Or
Going to and then jelly pipe. Okay.
And then hold on to that pipe. What would be a good name for that pipe?
Peanut butter and jelly pipe.
Good.
Then things get confusing to me though, because the sandwich.create basically it take the input from best peanut butter off the peanut butter. So really it's not the real peanut butter pipe to give us the best peanut butter. It is a job.
So that is completely valid. Let's do this one first and then do what you're about to say. Both of them work.
Really?
Yeah.
Okay, cool.
So
Thanks.
let's start with this one and then we'll refactor to that one and then we can talk about the differences.
Sure, thanks.
Okay, so now we have our pipe, and now we can add a process function.
No, so in front of the sandwich.create. No. Go back. So because you take the inputs and you put them in front of the method. And this is actually not going to be a process function. It's going to be a process. All right, so we're going to use a lambda. Because you have 2 things, you have to decouple them. So you're going to pass a lambda instead of just a method pointer. And it's a tuple, so how many parameters is it going to have? You put 2 things in the pipe. So what would be a good name for the first parameter?
Just to clarify, I don't know if you guys know about tuples. I'm not sure how are the other languages.
Yeah, it's called tuple in all the other languages too, though, I think.
In Java, we don't technically have that, but there's a lot of helper to give us that. But yeah, it's here. Java a little bit. Thanks.
Okay, so you pass the tuple, the peanut butter and jelly, let's call it.
So what do you want the first variable to be called?
It's the tuple, no? You pass the
So
tuple.
you deconstruct. So the process here is going to be a lambda that takes 2 things and returns 1. What's the first element of this pipe?
The peanut butters.
Good. So what's a good name for that? Lambdas, a lot of times we use the letter as the first name.
So P.
Good. J.
Okay.
And the second one?
So you're passing the two. Sorry, I'm confused.
Okay, so if you'll notice, IntelliJ is actually like also helping us out. So it's saying that like this is a lambda that takes two parameters. One is peanut butter and the other is jelly.
Okay, so you're saying what do we pass to sandwich create?
Yeah. So then, well, first
Okay.
we had to give variable names to the two things. Now we need to use them into sandwich create.
So say p dot and j dot best jelly. Okay.
Does that make sense to everyone? We're also missing a parenthesis.
Yes. The only thing it feels at this step, you're also doing so from this thing you need just a property of that thing. So you need the best peanut butter and the best jelly. So I'm not sure if that would make sense to have a.
So this is what Tony was saying earlier, and let's get through this and then we'll address that.
Okay. Misunderstood. Okay. So.
And what was the reason again that we use process here, not process function?
Because it's a lambda. Ideally both of these would be called process, and you could either pass a pointer or you could pass a lambda, but for complicated reasons involving the IL, those two names can't be the same thing. So process function when you pass a pointer to a method function, process when you pass a lambda.
Yeah, they're not quite the same in C# in IL.
Yeah, it actually has to do something more complicated with the fact that we're not actually passing a function here. We're passing the thing that represents a function. What is that called, Jay?
A method group.
Method group, yeah. That allows us to just do better printing. Anyhow, we try very hard to make those names the same. We can't.
What is IL?
Oh, IL is, you're a Java person, right? IL is the .NET version of bytecode.
Okay.
Right? So it's what C# compiles into that actually runs.
Yeah.
So let's create a collector for the best sandwich pipe.
I forget what it actually stands for. It's like instruction language or something?
No,
Intermediate.
Intermediate language.
Hmm.
And then on line 32.
Do you want to look at the picture first, or do you want to
Sure.
use it?
Let's look at that. Let's run the test.
Tony?
Oh, that's.
That is. You go ahead, okay.
Yeah, it's too many things.
Yeah. Can you go back to the code? Couple interesting thing I noticed. So.
Well, hold on.
Yes.
First of all, is the diagram right? What is the diagram telling you?
The diagram telling us that we can buy both the input, and then from that input, as long as we pass in the peanut butters and jellies, the tuple, it will come back and give us the sandwich, which I think is correct based on our assumption. But I just curious, what if we don't do the joy and we run the pipeline approvals? What do we get? So let's say if you comment down the line 19 all the way to
Then line
22.
21 won't compile.
I mean, but 22. Yeah, from line 19 to 22, then everything's just still compiled.
Oh yeah.
Now, run the verify that, run it again. There we go.
This is not
So which means that right now the way I read the picture say for this specific input, you have two pipelines separately. So which means that in theory, when I read that pictures, I'm saying when I'm passing in the zip code, I also need to specify what pipeline it's going to go through.
It's going through both of
handle
them.
that.
It goes through both of them.
Go through both of them?
Yes.
Because it's on line 15 and 17, you add the process functions to the zip code equals.
Yeah, so let's forget about the combine for now. So what if I say, let's say on line 27, when we send the zip code over, then that input will go through both of the pipeline?
Mm-hmm.
Oh, okay. That's interesting. So which means that, there will be two pipelines automatically hooked up to the zip code, and the moment that we send the input over, the input will be go through both of the pipeline at the same time.
Well, at the moment, it does not go through them at the same time. But yes, in theory, it could go through both of them at the same time.
Oh, okay.
At the moment, it's going through one, and then when it's done, it goes through the other.
Oh, okay.
That's synchronous versus asynchronous.
Yeah, right now, everything is synchronous.
Oh, and this is where the pipeline approval coming in to help, because basically the people model will getting very, very complicated. We would need to have some kind of picture to see what have we set up and how they all combine and collect together.
And it helps us to reason about our refactoring.
True. Yeah. Okay. So yeah, that makes sense now. So yeah, we can uncomment it from line 19 to line 22. And I think what's next is we just need a way so that we can change line 32. So now the pipeline has what we need.
Good.
Now, what we want is we want to replace that whatever after the equal sign with something along the line of best sandwich collector dot get something. Okay. Yeah, I think my turn done. Actually, before moving on further, I have a questions.
Yep. Pause.
So then right now when I look at the pictures, the picture essentially saying now is given the input, it will always give us the sandwich. So
at the moment, it's saying given the input, it will always give us the sandwich, the peanut butter shot, or the peanut butter and the jellies, because we have 3 collectors at the moment.
Oh. Okay, so then the trick here is as long as you give a collector for a specific process function, we can collect at that specific stage in the pipeline. So if you don't have that collector, then you cannot really collect the result at the specific stage of the pipeline. So one of the main reason why we want a collector is we want a way so that along the pipeline process, where do we want to collect the result?
Exactly.
Okay.
But now we don't need it anymore. The intermediate one.
You'll notice we got gray showing up on 30 and 31.
Yeah, so that means that we don't need line 30, 31. So now, which means that we can delete the line, anything that saying jellies collector and peanuts butter collector. Okay. Sorry,
yeah, you'll see that cascade. No, that's fine. Like, it's good to get understanding. And we've been making you do a lot without understanding for a while.
Okay. Alright, yeah, so I think not my turn. Okay. Thanks.
Robert.
You're on mute.
Yeah, sorry. So let's delete line 30 and 31. And then
refactor them. I mean,
that's fine.
There's a remove unused local variable, but it will. Oh, it works now. Cool.
Let's do the same here. And now we can also do the same for line 16 and 18.
That is where it doesn't
Before
everything we want.
methods.
Yeah, because that method actually has side effects.
Yeah.
So it's actually doing it correct, right? Like, but as refactoring, it's important that calls collect to keep it the same, because otherwise the graph would change. However, in this particular case, we no longer need it. You can delete it.
I want everybody to watch as I delete it. The picture is going to update on the left. I think this is so cool.
And that is done by ncrunch, isn't it?
Yeah.
Mm-hmm.
Because ncrunch is immediately executing this.
Ncrunch is immediately executing this, and Visual Studio Code is monitoring the file change.
Yeah. Yeah, nice.
Yeah, I think
Although I
just
expect that image to have updated already.
So that takes a while.
So verify passed.
Yeah.
The what?
Yeah. So verify. Oh, it has to be going. Have we approved it?
How did it pass?
We completed the exercise. There's already an approved way.
Okay.
All right.
Just as a note, I think a lot of people on my team, they love using Lambda and function. So I think this one can be helpful. We have something for Java side. The only thing is that kind of like the naming of the process function is a little bit off at the moment. But yeah, that's something we can kind of like working on. But I can see this one become very helpful for people.
Well,
because I don't know. I love Lambda. People on my team love Lambda too. So
Lambdas are useful. There's still some things to do here. The first is we really want to extract the part where we set up the pipeline. But the problem is we're using two things from there. So now that we've created the pipeline fully, it's really useful to get the inputs and outputs. And we have a method that will do that for us. Right. So it'd be nice to look at this and just be like, you talked about the concept of a pipe, right? Like, so it'd be nice to be like, here are inputs, here are outputs. And you can do that by get inputs and output, or get inputs and outputs. Is it just that? But that's not the best way. The best way
type.
Get inputs. And what is the type of our input?
Who are you asking?
I was asking the mob. Right, so this pipe has an input for zip code.
Yes.
Yeah, okay. So let's put zip code in there. And then, and outputs. And what is the type of our output?
Sandwich.
Good.
And then you can dot var that. So it says inputs 1, outputs 1, because this particular pipe has a single input and a single output. Right, but that's not a requirement of a pipe. And so now, instead of saying zip code, rotate. Oh, we got the bell for the first time.
I heard the bell already last couple of times.
Oh.
Here, again, some feedback. The same about the graph object. So again, you get inputs and outputs on the input, but it's actually on the entirety of the graph.
Yeah, it's for any node. So I
Actually, I
think
have
what
a
you're saying is
question
like
there.
there's some part of you that wants to be able to say, from a node, get the graph.
Then get inputs and
Even though
outputs.
it's not a thing.
Yeah, kind of.
Uh,
Or maybe this is, I am not sure right now how it will look like, but in my mind, conceptually, I see this as a graph. And
Yeah.
that has inputs and outputs. So that's actually, the fact that you get the inputs and outputs enforces the fact that this is not a graph. Graph. Okay.
Yeah, anyhow.
So, what do we
We'll
do
come back
with
to
the-
that. I think it's an interesting point. I'm not sure how to process it right now.
Actually, I think it's a good point because the code now suggests that we get the input for the input and the output of the input.
Yeah.
But it is for the entire graph.
That's for the entire graph.
Yeah. But what do we want to do with this variable?
So we want to use inputs and outputs only after line 24.
Instead of the zip code input.
Yeah. So
Yeah.
there you can put this to inputs and outputs dot input 1.
Okay.
The part where we're sending, you can change that to inputs and outputs. Send zip code. And the part where you're collecting, you can say inputs and outputs.
Oh, interesting. So, sorry for saying it again.
No,
At
it's
least
fine.
to feel like the inputs and outputs, it's actually kind of the concept of graph.
It is kind of the graph. Yeah, you're right. That is kind of the concept of a graph.
So why do we still need to have the input 1 attributes on line 26? So we want to verify the entire graph.
Yeah, but I assume the verify doesn't work. I mean, it has
Yeah,
to
okay.
be
I
input.
don't think,
mean,
yeah.
But we, so it would also work if we would take the output.
Yeah, it would.
Probably. We have a few flaws around that, but yeah, that passes.
Okay.
I don't know if anybody can see that, but there's a bunch of red boxes here saying you're failing, except this fact that it's a red box means we get past this line, we're failing down here. So when I say, oh, it's passing, that means it's passing through this line.
But now that we've done that, you can extract the setup pipeline.
So, may I ask a question?
Yeah.
So why you need the concepts of inputs and get inputs and outputs? At least to me, the first one actually, because it had names like zip code inputs, it was a little bit clear that I'm sending. I mean, which one? No, actually, the send one. I'm not sure. I'm a little. It's okay. Let's continue.
So we do need the concept of being able to get a single thing that contains the inputs and outputs,
Yeah.
right? Because we want to extract it.
The only thing I don't like that much is the fact that they have like input 1, output 1. So it'd be nice if it has more descriptive names.
Yes, that's very hard to do on an object.
Yes.
It's a little bit like a pair of tuples, an input tuple and an output tuple.
Mm-hmm.
And so in tuples, you have item 1, item 2. It's kind of like that.
Yeah, you don't get the
Maybe it should be-
descriptive names unless you happen to own the language and add it as a feature.
Maybe it should be called output item 1 and input item 1 to mimic tuple phrasing.
So at the moment, how many input parameter does the pipeline support?
I think it
Only
supports 4. Well, it supports unlimited inputs, but in outputs, you can have as many as you want. And get inputs and outputs, you can have as many as you want. But get inputs, get outputs only goes to 4, because I think there's a limit of 8 on the parameter
Yeah,
overloading
tuples go up
tuples.
to tuples go up to 7, and then the 8th is a tuple where one of the items is another tuple.
Yeah.
And so the
Maybe it
maximum
becomes a
of
mess.
inputs plus outputs is 7. So you can do 4 and 3, 3 and 4, but you can't do 4 and 4.
I see. Cool.
Okay, but we're just getting to the really interesting parts. So we can extract the setup of the pipeline now. So do that for me.
Oh, now I get the inputs and outputs.
There we go.
Makes
It's
sense.
a little better. Yeah.
Can you replay that refactoring? I expected a lot more lines to go into that new.
So I selected that.
It's only picking half the lines. Interesting.
What do
The
you
other
mean?
lines are not contributing to that.
Are you saying are we only selecting half the lines?
No. So we have 7 lines selected now.
Yep.
But if you refactor it, the new method only has 4, and the other 3 seem to be remaining. So that suggests that those lines are kind of obsolete or
No, it has also
mixed or.
the method that's being extracted is on the bottom.
Oh, it's on the bottom. Okay, I'm sorry.
Yeah.
No, that's right. I was confused.
And we actually want to make it public. So now we set up the graph, we send stuff through the graph, and then we get the result. Can we actually inline best sandwich? It doesn't really need to be its own variable. Okay, so now we have a fairly simple method here. And now Robert's point from a long time ago of why do we have test code in the middle of our production code? Right, so let's move that to our test.
How did you even set it up? Because so you mean that the production code has a dependency library on the test code?
At the moment, yeah.
Oh, okay.
I keep doing this wrong. I'm going to copy both of these lines. I'm going to delete this part only and paste the 2 copied lines over here.
So I think you have to fully qualify the simple case. Does that make sense? So we just move the test code into the actual test. Is that making sense? Let's do it a different way. Undo this. In the test, can you just inline the call you're making, Valentine, and then clean it up? I'll be right back.
Back how it was. Like that. Okay, now we're in a good state. There's one other thing that we should have put back here. This is logged and the test will pass, and it's an easier place to work in. Alright, go ahead, Valentine.
So set you inline the method, find best sandwich.
Yeah. We're going to inline this method, but we're not going to inline
Remove. Yeah.
at all, just this one.
Yeah. But the implementation is deleted from.
The implementation is still there.
Oh, okay. I thought inline. Yeah.
Yeah, you can inline and delete or inline and keep.
Oh, okay. And I wasn't aware of that. Okay. So the unit test. Oh, and so in this thing we have 2 things. So we want to verify the sandwich and also the graph. Isn't that 2 things into
So
one?
the original code wasn't actually verifying anything, it was just running.
Yeah, that's true. So we want to split it in 2 tests, one for just the graph and one for the actual running through the graph, or what?
So
No.
our goal is to stop running the code.
It's only verifying.
So then remove the 20 till the end of the. No?
Yep.
Okay.
So can you elaborate more on why our goal is stop running the code?
Because the code doesn't run. It throws exceptions when you run it.
Oh, yeah.
But then if we verify it just only the graph, would that give us the confidence that the code would execute the way we want it to?
It tells us that we're going to call these services. It doesn't tell us that the services are working,
Yeah.
but it tells us we are going to call these services in this order, passing these parameters.
Not necessarily in the order, because according to the graph, the peanut butters and the jelly could be executed in parallel.
The graph doesn't actually state that they're not at the moment, but yeah.
Yeah.
Yeah,
So which means that if we just verify the graph, we can only have the confidence saying that we know that these services will be executed. But whether or not it gives us the expected result, it execute the way we want it to, it doesn't give us that.
it doesn't give us that. The only way to get that is to execute the services, which you can't do.
And why can't we do it? Just
Because the services explode when you execute them.
and what is that?
One of the
Have you
services
called
is
services before?
one service buys something on eBay. So every time you run the test, it's at least a couple dollars. And the other one launches the missile.
Nah.
Oh, that's cool. That's cool.
In theory, actually, I like this approach because you have unit tests for individual functions. So for each
Exactly.
positive functions, you have, and so that don't necessarily they have to be external calls. No, they do some processing in memory or something. So you can test those, and then you have the gluing up all these things together, and you verify that is the way you want it. So this way you don't have to unit test what I don't even call a unit test the whole thing. You test it by having the graph of objects be what you want, and individual nodes test it as unit tests. This is my mental.
Let's get this test to actually pass. Like, where should this test end?
Line 19.
Good. So let's delete everything after line 19.
And delete also the zip code on line 15.
Yeah, because now it's dead. And now this throws errors, right? If you call those services, but this test passes.
Okay.
And now let's.
Mentally, this is kind of like a function pointer versus the executing that function. So,
Exactly. So now let's go back to our actual code and clean it up just a little bit more.
Let's delete this next comment.
Yep. Oh, good point. So now in the code, we no longer need to be doing our test code, so we can get rid of that. Send through pipeline is less useful for send. And original code is no longer useful. So now our method in the beginning has really simplified. Right? We create the best sandwich graph, we send something through it, and then we get the result.
on line 28, you can remove that. You know?
Yep. We no longer need that collector. Oh, no. You do need that. Sorry, go back. You need the collector. You no longer need the variable.
Wait a minute. If we don't, I don't see that collector return any result. So why do we need that?
It does. It does it on line 16. If you send things through the pipe and you don't collect them, there is no result of sending something through the pipe.
Yeah.
It's equivalent to doing a link statement of like find first, right? Like, so if you do like do all this link and get the first, but you don't hold it on as a variable.
Mm-hmm. But so maybe as an improvement somehow, if you get the outputs, you also have a collector. It's.
So if you ask for outputs and there are no collectors, it will complain.
Okay.
Yeah, because the main thing that I know likely people will forget is whenever we put in the effect or the cause too far away from the effect, people will have a tendency to forget about it. And because on line 28, suddenly there's a collect statement, and then all the way down on line 16, that is the reason why we need to have a collect statement. So which means that there's no way people would be like, why do I want to do this collect segment here?
So you always need the collector on the
I mean,
output pipe,
you always
or
need on the whatever the last thing is, you need to collect.
Yeah,
it.
I mean,
That's your output.
from the implementation perspective, we need it, but from a user perspective, they don't care. And typically, we all go ahead.
I know. I was saying I agree with Tony
Yeah.
on that one. It's a
It
little,
almost feels like what you're saying is when you say get inputs and outputs, if there isn't a collector, it should put it on.
Yeah, something along that line, or
Yeah, that's fair.
as well. Yeah.
Okay, but so now we have an interesting thing. We have a test of our process with where we can't run any of it. We still haven't done the thing Tony has talked about, so I thought it would be good to come back to that. So Tony was pointing out that like the way this pipe goes, we go and we get the peanut butters, we get the jellies, we join those together, and then we call the best peanut butter on the we get the best peanut butter and the best jelly out of the peanut butters and jellies. But maybe the pipe should actually look different. Maybe from the peanut butters we should get the best peanut butter, and from the jelly we should get the best jellies, and then we should combine those.
yes.
So we could take the best peanut butter pipe and say peanut butter
Universe pipe dot plus.
to get the best peanut butter, and then do the same thing with the jellies pipe.
Oh, we actually adding 2 extra pipe.
We're adding 2 extra
okay.
pipes, which totally legit. We'll talk about how these two are different and what are the advantages and disadvantages of each in a second. So stop for a second, and right now our graph should change. Are we looking at the approved? Can we look at the received? Is that the received?
Yeah, it's because it's only tracking up.
Oh, that we're not getting it? Yeah,
think so.
the traversal of the graph is complicated.
We'll see what
Okay.
happens if we make another change here. That should show.
That is not showing up though.
Here. I can't read any of this. Yeah, there it is. The preview, if the file gets deleted and then recreated, the preview doesn't refresh.
Okay, good. This is it. It is traversing
There
correctly.
you go.
Good. So
Cool.
right now, we have it going through, we're joining the peanut butters and jellies, and we're also taking those pipes and making pipes that get the peanut butter and the jelly. Does that make sense? So now we're going to join the peanut butter and the jelly. I'm very curious to see how it handles this. Yeah, well, that's accurate. And then off of that join, which gives us a tuple of peanut butter and jellies,
You can just write sandwich.create here. Oh, it doesn't take a tuple.
No, it doesn't take a top, unfortunately. This is one of the feedback that.
yeah, that is remarkably complicated. Like the fact that we have a tuple here that automatically decomposes for you is already like pushing. And we were trying to deal with like how do you have no multiple parameters, and it's it's tuple, 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 right?
Yeah.
And it's sort of like what you have to do to make it generic. And now we no longer need 31. Yeah. And that's a much nicer. You're still joining.
20%.
So there we go. So now we take our zip code, we go to the peanut butters, we go to the jellies, we get the best peanut butter, we get the best jelly, we join them together, and then we create the sandwich. All right. And the advantage of this is if the get best peanut butter is long or the get best jelly is long, this will make a significant difference when you make it asynchronous.
Mm-hmm.
If it's short, the other one was simpler. Right?
What do you mean by long and short? I mean taking a long time to
So
execute?
let's say that get best peanut butter is another service call that goes across the
Okay.
wire and takes 2 seconds.
Okay.
Right? So if and the best jelly also takes 2 seconds. So if you run them one after the other, it's 4 seconds, and if you run them in parallel, it's 2 seconds. Right? It's just whatever the longest one is. Because either way, it doesn't join them together until they've both completed. Right?
Yeah.
But we still haven't done the other thing. Like, all of this has just been a refactoring. We haven't yet done the thing where we turn it into asynchronous. So we need to do that as well. So Jay just did it, but he did it really quickly. So let's call it out. So you see here on line 4 where we have refactoring.pipelines. We're going to do refactoring.pipelines.async. Now this code runs asynchronously. So that's the actual convert your code to asynchronous code.
Yay!
That might break your system, by the way. Asynchronous is not a refactoring, right? Like, you want it to be a refactoring, right? You hope it's a refactoring, but it is by no means a refactoring, right?
Why does it break the system though? If we change it to async,
It might
technically-
break the system. Well, for example, right now, when you do this, the get peanut butters and get jellies are called at the same time. Possibly the jellies are called before the get peanut butter is finished or even started. And maybe your get jelly shop is using the login that comes from the get peanut butters.
so is there a way we can specify the order in the pipeline when they are parallel?
I mean, if you want the jellies to occur after the peanut butters stops, you need to make that pipe feed back into the jellies.
I see.
Right? But the point here is, if there's any kind of shared state between them, then moving to asynchronous can be a problem. Likewise, there could be problems just with timing, right? Like, some systems require that things take a certain amount of time, right? So there might be something that, waits 4 seconds and then calls it. And if your stuff only takes 2 seconds, the state will have changed before 4 seconds gets around, right? Like, these things sound crazy, but they really exist in the real world, right? There's a lot of stuff that is state-wise dependent, and worse than state-wise dependent, hidden state-wise dependent, where you don't know and possibly no one remembers that these two things actually need to be connected for it to work, right? This is why, like, when your computer's really like foobarred, you just reinstall the OS rather than trying to figure out like what's wrong, right? Like, there's a point where it's just like hidden dependencies are really complicated. So what the advantage of this is, by changing line 4, that is the only thing that changes when you release to production. So you release to production just based on the refactoring, everything is working good, You change it to async, that one word is changed, and you re-release to production. And if anything goes wrong, you know why. It has to be that you moved it to async. And now you can start doing what is otherwise, and still is, a very complicated debugging system of trying to figure out why your async code isn't working like your synchronous code. What is your hidden dependency? But at least you know it is a hidden dependency, right? Like that is the advantage of being able to do the refactoring. I'm using refactoring quotes. That's the ability of being able to do this as a very isolated change. The only thing that changed is we decided to run these things in parallel.
Is there anything that is similar to this pipeline library in other languages, or this one is kind of like the first pipeline library that we have around?
This is not the first pipeline library. There is definitely a lot of, like, almost any pipeline is going to look very similar to what we're doing here.
Yeah.
And there are a lot of pipelines. What's different about this pipeline is it is set up to refactor to it. Most pipelines are set up to make composable pipe pieces. Right? Most pipelines are set up to create little pieces that compose together from a greenfield situation.
And which you can do still with this.
Yes. But
you can take a legacy code and refactor it to pipelines.
yes.
Yeah.
Arlo has talked about a desire to make this just like link-wise compatible, but he's not done that, and I don't quite see. I see problems with it. Arlo is
You
often
can
right
make
when I'm
select be the process the next thing.
yeah, but we still have the problem of the double select word.
So I really like the idea, and I said not necessarily for the moving to async,
yeah,
but in terms of seeing your call graph in a way is a graph, and I like that.
And so one of the things that's on, now that we have the ability to automatically generate, like right now we're generating this, opening it in Visual Studio Code and rendering the thing, right? But if we use the code we recently created, but not yet released, we could skip the visual code part of this and just go straight to an image. Does that make sense?
Mm-hmm.
And if we start exploring the other thing we've been talking about a lot, which is let's use MonoCecil to inspect the code and generate the graph for us.
Have you guys thought about Roslyn?
Yeah, in my understanding, MonoCecil is a lot easier to use.
Okay.
Have you had a different experience with that?
I haven't used either of them.
So that's not a dish against Roslyn. I believe Roslyn is more powerful in many things. But my hunch is that you want MonoCecil from people who
thought about composability. So creating graphs of graphs. So each node is a subgraph, so you can do some.
I mean, you can already do that. Right, because the nodes just
inputs and outputs.
Yeah, you just wire up another pipe to. The fact that the pipe has stuff underneath it is irrelevant.
Okay. Have you guys thought about eliminating the joining? So, from the user perspective, I don't know how feasible it is. It would be nicer if Jay, can you show the graph again, if that's okay with you? So instead of having a join and creating a tuple, somehow the peanut butter and jelly go directly into the sandwich create.
Well, I mean, in this particular case it does, but it really depends on what comes out of that join.
So this is what I'm saying. Instead of a join, you have the peanut butter and jelly go directly into
but you're assuming only one thing comes. So how would you represent that if the tuple was used for two things.
That's a good point.
Or if
you still had two arrows from
both of them, going to both of them?
yes. Because to me, joining seems a little. I mean,
There's actually like 3 different types of joins too, right? Can you pull up the doc page on joining?
Oh, I'm saying, but it will make the graph a little
Simpler?
thinner in some cases. As I said, it was just some feedback.
Yeah. No, I understand what you're saying, but like we run into this problem of generically showing things where only like we're looking at how do we make it simple for one, but we have this ability to join. You have the ability to capture the join, which would get really confusing if it didn't exist. So like here we are collecting. We have apply to, which, so here you have a prefix and values, and now you have a list of tuples of prefix and values.
Okay.
Right? So if you had, so let's say you had the, scroll down, or we actually have it above, right? So here we have apply to,
Join.
yeah, so here we have the numbers 1, 2, and we have the prefix pound, and then when you say apply it to, you get this result, pound 1, pound 2, right? And so here you're taking a single result from one pipe and a mini result from another pipe, and then you're taking the single and applying it to each of the mini, and then creating a new mini, right? And then if you go down again,
so you have concat of 2 lists.
right? So we have a list and another list, and then we're putting those 2 together.
So I fully agree with some cases, but in some cases it's the fact that you cannot you have to pass a single thing to a function. It would be nicer if you can pass maybe multiple things. I don't know.
Yeah, and that's the whole reason of overloading that lambda. Like the ability here to say process PJ.
Yeah.
That's a convenience function we wrote because we do care about that concern. It's just a question of like how do you handle that concern generically where it doesn't show up in the graph. And it feels like there's a lot of logic to figure that out.
I wish we could do this. I feel like honestly it was maybe inching towards, instead of join, just make a tuple, and then tuple process.
Maybe. I'm not sure how. I'm not sure if that would be an improvement. I say not even a tuple. I don't know how it would look like. I'll have to think to say in terms of from the user perspective how would you. But it was an idea.
Yeah.
Can I give some other feedback?
Oh yeah, please.
So the async code. So I like the switch to the async code. The thing is, this thing is not really async. So
The async code is not async?
in the sense that, for example, if you execute this on a thread, so you get the single result, you still synchronous. So for example, if you execute this,
I don't believe it is. Why do you say that?
No, in the sense that if you execute this in a thing that might block, like UI, so in .NET the UI thread blocks. So if you execute something on that UI thread, the UI freezes. So of course, even before the refactoring, this code was still freezing the UI.
Oh, I think I understand what you're saying. Can you go to the send method, Jay, in async?
The implementation of it?
Yeah.
So, no. It's up here.
Yeah.
So what you're saying here
This
is
is you want the async send,
I
right?
want the async send here. Yeah, that's a really good point.
So you need async, but you still okay. Show me how to send async.
You go click there in the input one, that's send. But and this might, I'll now have it lost. Are we still in async or not? Or in pipelines?
We're not. Let me bring up the real project.
Even if you send async, this is what I'm saying. If that code executes on the, for example, on the UI thread, you still need to use like the
Yeah.
async.
So it runs the code asynchronously, but the entire wait process is blocked and not asynchronous.
Yes.
Yeah, and
Yeah.
that's totally valid. And it would also require a different method signature.
Yeah. So I suspect you like send the sync and somehow on the result you do something, you await. I don't know.
So yeah, this is an oddly interesting point. Because right now there is no result; it's just a void, right? But from send.
Yeah.
Can you do an async on a void? I feel like you can.
You can have a task.
Yeah.
But async void is terrible. You can have a task that doesn't have a type, which is the moral equivalent of void.
Yeah. So so what he's saying is like, even though everything on there is running on separate threads,
Mm-hmm.
the thread that calls it is still waiting, is still blocked.
Yes.
And so it's parallelizing the process, but it's not divorcing the process from its parent process.
Yeah.
And that is like a very valid point. It feels like there should be, like, moving async means everything goes in parallel, but you actually, if you want to divorce it from its parent, you actually need to call a send async that returns a task. And since send returns a void, not a task, you need to do that right away.
I feel like that's a really orthogonal concern in that even with a non-async pipeline, you might wish to do that. Right? I'm not saying that you should, but you should.
Actually,
you
that's
could
a fairly good point.
take
Even
the
with a
entire
non-async
pipeline and execute it as a task.
synchronously, but get it back to me when it's done.
Yeah.
Instead of blocking for it. Give me a call back. You're right, it's totally orthogonal.
And that could be useful in that you have a consistent signature. You have a send and you have a send async that exists on both sync and async implementations of the pipeline.
Yeah, that's a good point too. Can you add that in our to-do list?
So I like the idea of the send async. I was thinking the solution would be to actually the result somehow to await, but actually awaiting on the send might make sense. And then
I'm sending the send still blocks. We run asynchronously, but the pipeline is run asynchronously, but the send still blocks still both the pipelines. The parallel pipelines have finished.
Exactly. That's what he's saying.
Yeah. The only thing I'm just thinking out loud. If you have two inputs, you'll have to. So if you see send async, you have to combine them. You cannot await on both of them because you
Send doesn't return anything anyways. Send just tells you that it completed. It just returns I completed.
It was just a small thing. I was saying if you use the wait on the send async and you have two inputs, you have to wait. It's kind of weird. You have to compose them. I mean, say async one without a wait and then a wait on the both inputs. if you send the scene. That's a detail.
Huh.
Right? After we can talk when we have
When
it
we're
sent.
implementing it. But you're right. It's a separate concern, but it's a valid concern. Out of curiosity, can you not just do an await and then do a lambda of the call to send?
You can do it like a task create.
Yes,
Which says
Yeah.
take this lambda.
You can create a task and then later you can await on that task.
Yeah.
And I mean, if you need to await, yeah.
But it's yeah. I mean, probably that would be our implementation of it. Is it that simple? Can you open up the code and just check that for a second?
Which code do you want to look at?
Where do we call send on? Input pipe? Must be input pipe. Might be input pipe. But probably input pipe.
Are you thinking about it right here? Or are you thinking in the pipelines class?
In pipelines class.
So guys, I'll probably have to drop because I'm on call, so
No worries.
thank you very much. It was very useful to have the tutorial, so now I understand better.
One quick question before we go. Anything you're still not understanding?
I think it's much clearer. I don't think I have something that is confusing for now.
Okay. All right.
Okay.
We'll see you later. Thanks for joining.
Thank you. When do you guys plan to do the next week or 2 weeks or
Yeah,
what's
it's interesting how much just having a 1 week shift through a spoken is.
We can do 3 weeks until the next one, and we're back into the old shifts.
That makes sense. Let me pull up.
Or in a week from now.
We can't do a week from now. That is the whole reason we're here.
Alright.
3 weeks sounds like a good thing. That would be the 15th. The 15th, is that correct? Alright. I'll set it
Okay,
up.
thank you guys.
Thank you. Let's do retro.
Alright, I'm ready for retro input.
So let's start with putting those 2 items on that we had before. What happened and questions and things I don't understand. And Jay, I want us to answer the what happened, but I want us not to answer it until Robert and Tony are done. So help me to stay quiet.
So you want to do the what happened?
Yes.
But so we should not do it.
Yes, please.
Okay.
Tell us what happened. What did we do today?
So we followed the tutorial.
Okay. Keep going.
We kind of yes, we kind of doesn't really get it on the first try, roughly about 10-20 minutes, because I guess it's not. I'm not sure because we are completely new to it, or is it because we just need to go through the material once to get it.
Go ahead and tell me everything that you noticed, everything you saw, every observation.
So before we followed the tutorial, we had this explanation about lambdas. And then about wrapping that in an object.
We don't understand about why we want to use collector in the first place.
Yeah.
And we don't understand why the big pictures when you try to explain it for the first try.
Was confused about doing a verify in the middle of the code and not in a test. And I'm not sure if it's a right or a correct wording, but in Dutch we would say we had a couple of pennies dropping. Like it started to understand it.
Do you remember any of the particular pennies?
No. Mm.
Huh. What else happened?
We had some discussions about sync versus async.
We rename from kind of a method call to we try to changing updating the readme from a method call to a method.
Mm-hmm.
For me at least, I started to understand it the moment that I see the approval pictures. Because only when we get to the stage where only when we get to the stage where I see the pictures of the pipeline join together and return the result. That is when I started to pick up on it.
Yeah. So the join to is the part where is one of the pennies.
Yeah, actually, that is one of the penny, and also only when I see the approval image for that join to, then I started to pick up. And then go ahead.
Yeah, the other penny was that the input gets sent to two parallel functions in a single send call.
Sorry, say that again.
So when you call send, that input gets sent to two parallel pipelines, where you would otherwise make two calls.
getting confused between the process function with the collector.collect.
All right. Anything else?
Yeah, I like Valentine's suggestion that the collect method maybe would be better named get collector.
But to be fair, like, you live in Java.
Well, I think the collect. My expectation with the collect is that it then actually starts waiting for the pipeline to finish, and that's the blocking call. And that's why I was confused that we do the collect first and only then do a send.
But the expectation with the getter is that it doesn't. My expectation with the getter is that it doesn't modify the object.
Fair.
Whereas
So maybe a build collector then.
build collector.
I think that was actually also his suggestion.
I don't know.
Alright, collector.
Yeah, not bad.
Also, kind of, I guess, kind of see it getting together when at the end we remove all of the extra collector call. Once the job finished, we remove all of the extra collector call, and that is another aha moment there.
That's one of those pennies.
Yeah, one of those penny. Also find surprises when the production code actually has some dependency on the test code.
This is also a penny.
That's not really a penny. I would say that is more.
This is actually
There's mine.
the one right above that. Very confused about verify in the middle of.
Yeah.
Yeah.
Yeah, because my production code should not depend on the test code.
Yeah. So interesting thing is, like, when everyone talks about like testing external methods. Oh, sorry. Have we gotten all of this stuff?
Yep.
What about questions or things you're having trouble with understanding? How are you doing on that side? Other things we should talk about.
Question then. How can changing from async from one line, how come changing to async one line that break the system? Where does it actually break the system? Other question then is, are they executing parallel when the node on the same level? Other question.
I think yes.
No.
Yeah, go ahead.
So if they are in parallel, the order is no longer guaranteed, and one time it might execute the first and the other one slightly later.
No, but more
And
than that.
the next instance it might be reversed. But that's no longer guaranteed.
But more than that, like if we go and open up that graph that we had at the end, right? it might call the process peanut butter.
Honey, can you turn off that so it doesn't make this
No, I need to talk.
alarm?
Oh, the alarm?
Thank
So it might call the jelly shop get available first. It might call the peanut butter first. But let's assume right now that it calls the peanut butter and then the jelly. But the jelly returns quicker. So now, while it's still calling the get available peanut butters, it's now calling the best jelly. And that returns quickly. So now it's waiting on the join. And then it calls the best peanut butter because it slows down. Or it might call the peanut butter and the jelly and they take the same amount of time. And so now it's calling the peanut butter and the, like, does that make sense? It might step down the levels together or it might not. The join points will always be a synchronization point because there's no way to go past the join until you synchronize. Right? But up until that point, the zip code starts together and the only thing you can be certain of is the join will have both things before it moves on.
So a couple other questions regarding to this is there any other pipeline library like this for other languages? And what is the difference between this pipeline library with those libraries?
There are lots of other pipeline libraries. That's an excellent question. What is the difference? Because the other pipeline libraries you don't use this way. Jay, you got any idea there?
I have not used them, so we should check them out.
Should.
Yeah, more specifically because my main contact is on Java side. So
Yeah, so there's
the
something
reason why.
called Apache Beam.
RGB? Okay.
Yeah, go from Apache.
Okay.
I've not used it. It is a pipeline library. I do not know if it runs synchronously. I think a lot of pipelines don't run synchronously. Like I'm pretty sure this is one thing that's different. Another thing that I'm pretty sure is different is the ability to visualize it easily from a test.
Yeah.
Although most other things do have something that will visualize it. It's just not usually. It's usually like you take these pipelines and you deploy them to. So most pipeline things are meant to be orchestrated, right? So like Jenkins pipelines, right? Like you create your stuff and you send it to Jenkins and Jenkins orchestrates it and does the stuff, right? One of the things about this pipeline library is it is not trying to do the orchestration for you. You create the pipeline, you call it, you get the result, pipeline disappears. Does that make sense?
Yeah.
Most
So couple
pipelines are
other-
meant to be
go
called
ahead.
more than once.
Okay.
Oh,
Couple. Go ahead. Yeah. Go ahead.
These are
What
very
is that?
disposably.
does it imply that these pipelines should always be short-lived and that long-lived pipelines cannot
It doesn't have to be,
be run?
but they very well can be. The idea that they only exist for that method call and then they disappear, that is something that I think is very different than most pipeline libraries. Most pipeline libraries are, I am creating a pipeline and you're going to throw stuff through it. Does that make sense? Like, you can think of it like an ETL transformation or something. Like, I put up this pipeline and then once it's there, people subscribe and just start throwing stuff to it. But like I think this is a big difference. I'm not sure how that plays out as much, other than, we're not registering the pipeline with anything. We're just creating the pipeline, and then we're calling it.
And then a couple questions that we had is one of the key things. So then, because we create a pipeline, then we would need to have a way to specify if this node or if this task is executed before the other task.
So that you need to do a synchronization. Like if you want one node to occur before the other, you need to make the result of that node feed into the other.
Go ahead. Yeah.
You have talked about a way to say these things must run in an order due to some invisible dependency.
Yeah.
I can imagine that showing up here with some kind of dashed arrow where this operation is up higher and this one is down lower, showing like it must go from that one to that one.
Yeah, I feel like
That would
this
be a
is a
thing.
version of a join, right? Like, like maybe you need the best peanut butter to occur before the jelly, and so you have sort of a wait until that takes the peanut butter, and then joins with the zip code, and goes to the jelly shop.
It's funny enough. I should say, I was actually, I couldn't run away from it, but I am mainly dealing with the view automations, and whatever the scripting language I work with, I very often need a way to make sure that
Something
I
is completed.
orchestrate the task. Most of the, no, actually, I should say more specifically, I'm mainly dealing with Gradle. By default, all of the tasks running in parallel, and they having difficult and trouble to make sure. Basically, they provide us with a model to say which one run after which one.
I mean, we can do this. Can you go to the code really quick, Jay?
Yeah.
Do a peanut butter.join to.
I can see where I totally understand your point there, but
just give me a second to actually implement it.
Sure. Yeah.
So we want the best peanut butter pipe. That's the one we're in, right? Okay. So the best peanut butter pipe. There we go. So no. I want the that I want to do a join to the zip code input, and then I want to take the jellies pipe on line 27. All right, so hold on to that one. And then we're just going to redefine the jellies pipe here. So just on line 32, you're going to say no var, just jellies pipe equals. And you need it at, here. Jellies pipe equals join pipes dot process. And then so it has p comma z goes to what does jellies actually do? Jelly shop dot get available of z. And then I would comment out line 27.
Comment out. We have to declare this here.
Yeah.
Repair some of the damage that I did. What do you want the rest of this to look like?
The way it used to. So get rid of the tuple and put in the other stuff, yeah. So delete the tuple. Yeah. There we go. We have join type twice. So
Oops, sorry.
can you call the first join pipe a wait till? There we go. And now let's go look at that image.
Is it?
There we go. So now we are guaranteed that you're not going to go and ask for the jellies until the peanut butter is finished.
Mm-hmm.
Right? And what would be nice is if that
Yeah.
join was like a wait and there was a dashed line that sort of connected it to.
I kind of totally see this. But then would it be easier if we can have something along the line of saying jelly pipe dot must run after peanut butter pipe, and
I mean, that's
that
sort of what we're
basically-
doing here.
Sorry.
That's sort of what we're doing here. You're just asking,
It
like,
is
would
sort
there be
of-
an easier way to make the API that way? Like, there's actually
Yeah.
a more fundamental question to the API, which is when we wire up the jelly pipe in the order we did, should it automatically put it at the end of the, like, right now we're doing it at the best peanut butters, but the way the code was originally written, this join would have come off of the peanut butter pipe, which is trivial to do. If we just go to the await pipe, instead of going to the best peanut butter, just join it to the peanut butter's pipe.
Yeah.
Right.
Yeah, and the reason why I kind of mentioned that is, again, when we're doing the await queue, it's more like the implementation of how we want to ensure the order between the pipe. But from a user perspective, all they care about is I just need to have this thing running after this thing, and
Well,
you handle that for
So
me.
the thing is, like, this, the way this graph looks right now,
Yeah,
there's a question of if you are not in async, should this graph look like this? If you construct it using the default pipeline, should it automatically do this? So such that the refactoring, like, this is guaranteed. There is a chance in our refactoring that's not a pure refactoring right now, right?
Could
That
we assume that order and timing matter in this new design
yeah, and
and preserve
specifically.
items?
The difference between this and what we had before in the way that our current pipeline is created is if best peanut butters write something to disk that or even a global variable that jellies reads, right? This would mess it up.
it's not necessarily that something jelly read, but it's more like something jelly has to be executed after.
Yeah. Oh, so another example would be the log file could change. The way the logs are
Yeah.
created would change. Meaning it's not a pure refactoring, and it should be a pure refactoring because legacy code is mean and dangerous, and you want that safety of, okay, I realize this is crazy, but it is what we were doing before. And then when we go to async, this graph actually changes, and those sync points disappear.
So I think
Yeah.
the way that I've been thinking about it, at least, is whatever pipeline you build will execute in the same order as long as it's synchronous. So if there's two things that appear parallel in the graph, they will always execute left to right, whatever that means, because that's the way you assemble the objects. And as long as you are diligent in your transformation about each statement becomes one node in the pipeline, then you'll get that. But if you decide to break out the access of those properties, when you do that, you might change the order of things. So this needs to be some more discipline, some more instruction about how to break up a statement into pieces while maintaining order operations.
I don't know. I think like in the end, I'm going to give you tests where you need to do this. But that's in the future. But the point being that like this is a really real thing, and discovering it, you cannot do at the code level because it might not happen at the code level. Right? It might not happen within the system, that synchronization point.
Why do you care about what might not happen at the synchronization point? I don't get that part.
So the fact that one call depends on another's call might not
Yeah.
be in the system that we're doing, and therefore it's impossible to do any kind of runtime analysis or static time analysis
Or
to determine that.
that might not be in our system.
Might not
if
be in our
we-
system. Yeah.
If we're making 2 calls to another system,
The
maybe within that other system there's a dependency that we are not aware of.
Exactly. And like literally, like that is a common thing in legacy code, right? Like you are using some other system that has like a database trigger is this exact situation, right? Any system that has a database trigger has you call one service and you call another service, and that trigger is actually mutating data in between those calls, and so the order of operation matters. And you can't see it because you don't know that trigger exists.
Or your test might become flaky and
Yeah.
Yep.
you might pass runtime and you might fail the outtime.
Well, you talked about the imagine if it logs in. Like, I can totally imagine somebody who is feeling a lot of pressure to get the current work done, and they know, oh man, we gotta fix that login problem. And so they go to get peanut butters, and they just, on the first line, they write to do, fix this later. And then the next line is log into the system.
Yeah.
And the date on that comment is like 1998.
Yeah.
And it's been like that forever, and nobody knows.
Yeah.
That just happens.
I mean, it happens all the time. People are doing amazing things under like very limited knowledge and a lot of stress, right? And so very often, like, you know, the thing that runs your business is remarkably complicated and nobody remembers, and like what we want in refactoring, because the real danger that shows up here all the time is you refactor some code and it works and nobody notices. Like that is literally what refactoring basically means, right? Definitely no business person notices, no tester notices, no manager notices. Maybe your fellow programmers notice, right? But no one else does. You refactor some code and you break something and everybody notices, and then they tell you to stop doing it. So you have to be extra safe in these refactorings, otherwise people tell you to stop doing it. You write a feature and you break it, no one ever tells you to stop writing features. No one's like,
What do you think of a test strategy where you might run this process? We're not launching missiles with when calling services, but I can imagine that you want to run this test and then maybe build in some artificial delays to get all kinds of permutations in. For my first test, I'm gonna call A first and then B, but in my second test, I'm gonna call B first and then A.
So an interesting thing is, because we now have the code as configuration, you can do that, right?
Yeah.
You could go to the pipelines and say, like, calculate all the different permutations of how this could run, and then force it to do all those different permutations. I'm not sure how I feel about that, but this gets into something that me and Jay have been really thinking about for the last year almost, which is Arlo presented this as a nice way to refactor to async, which we agree about. It also turns out to be a really nice way to test this code, right? Like, I can test that this stuff does it without calling those services. And if people, like, if you look at people who test, they'd be like, oh, you should actually call those services, but with mocks, which is the same as not calling those services. Like, in neither of those situations are you actually calling the service, right? So it's not, and you're not actually gaining the advantage. This is testing that without mocks. Like, there are no mocks here, right? So the interesting thing here is this code, which is really hard to test, becomes really easy to test. That's a benefit. We believe that once you have this ability to have code that at runtime is inspectable, there's going to be a lot of interesting things you can do in it. We're just not sure what those things are. So the thing you just mentioned of, let's test every permutation of the way these can run, that's interesting. right? I don't have, I'm not sure what to think about it yet because I haven't gotten to try it out, but I think that there's a lot of things that this opens up that have been currently out. There's Brett Victor has this talk called Thoughts You Can't Think, and he's like, like for a long time we never saw infrared, right? And so we didn't think infrared existed, and then we built tools that allowed us to see infrared light, and now we can think about this thing that we couldn't think of before the tools existed. That like what our brains can go to is actually limited by what is possible. That our brains have a tendency to stay within the possible. And so I think this changes what is possible. And I don't know what the effects of that are yet.
Okay, so I can add to that because basically based on my experience with doing all of the view automations and task orchestrations, I have a feeling that this one heading toward become some kind of. So first, it is a functional kind of supporting the functional paradigm. Functional is just really just a process, and then suddenly this one it all become a task or process orchestrations because of our ordering between the process. So that is my feeling how this kind of going to evolve to. That is my impression at the moment.
Yeah, I mean, I'm expecting to be surprised on what we discover once it becomes more feasible to use.
Yeah.
The library makes this more feasible. Like that is a process that we could do. But I think, with stuff like the monoCCL or reflection, like being able to hover over a method and having it just automatically refactor to this, right? Or even temporarily refactor to it so that we can inspect it that way. I think it's very interesting.
Yeah. Go ahead.
I would love that picture and a tool window over here for my current function at all times.
Yeah.
Every function I look at, you just get to see that little graph.
Little.
Actually,
what methods are you looking at?
Yeah. Funny enough, I should mention to both of you too. So basically what happened is Gradle just started out as a task orchestration. It took them 5, 6, or 7 years to give us the Gradle Enterprise where all they do is visualize all of the task back. What task is executed after another. What we have here is automatically we give people, hey, if you're doing these pipeline, here's how the tasks kind of related to each other. That is my take on it. That is interesting enough. So for me, the benefit that I really take away from this one is if I'm doing this pipeline, I have a picture to visualize, so which is become very, very helpful. Now, what is missing as far as I can tell is how do we specify the order, preserve the order, maintain the order, because really, so first, I can see people using this one a lot because a lot of cases I want to write parallel code, but the current way of doing parallel code is very annoying and very painful. So this one become an easy way for us to do all the parallel code and doing the async. Not just calling the service, just doing computation, regular computation. But then the next question comes down to is when something happened, I want a way to visualize how the tasks related to each other. And that is where that task help us. But then the next question comes down to is how do I ensure the order of a certain task? Those are the question that I can see coming up. Yeah.
Other things we should get in the retro before Jay and I add observations. All right. Jay, you want to go first?
Machine was not set up.
Yep. And it looks like something went wrong in the setup.
Yeah, the Visual Studio install failed the first time through, and then the things that depended on it, of course, couldn't work.
Yeah.
And
Did it work the second time?
reran
Too?
it looks like yes.
There was I noticed like
There it is.
because I used to use the single driver a lot. It's a really effective way of mobbing when you don't have a machine set up. But this helped me to appreciate how much nicer it is when we have the EC2 instance.
Hmm.
Right? Like the actual rotation of the mob where people are like that, it just feels better.
Why is it better?
Before we get to that, do you feel like it was better? Do you feel like the way that we do it normally, where we're all hands on key, we're all talking and typing, was an improvement over what we did today, where only Jay was typing?
I had to be less concerned with the syntax.
Yes.
Had less context switches from being a navigator to a driver and back.
Yeah. So it sounds like you're saying you like this way better.
That's why I'm also asking why
Yeah,
you think.
no, that's why
No,
I
it's
wanted to ask. I was wondering if you were asking why I felt it was better, or what were the things that made it better. Does that make sense? That's why I wanted to ask that question. So the reason. Oh, sorry. Go ahead, Tony.
So maybe the reason why you find it better is because it goes faster, because Jay typed it, and then the rest of the team just input their ideas. But as a note there, then people probably less focused when they're not typing.
So the reason I thought it's better the other way is, well, first of all, I noticed that just we were worse about rotating, right? So who was navigating became much blurrier in this time. We missed our breaks a couple times. Like we were just worse at doing the rotations. Also, I feel like it was easier for things to get confused in this part, where people said things that Jay typed, but I'm not sure if he was actually typing what they wanted him to type. Does that make sense? And we never got to check that by saying, like, you know, when Robert was at the computer, did he understand it? Or when Tony was at the computer, did he, like, we didn't get that verification check to make sure we were all actually in sync. So that's why I felt it was worse. Also, there was lag that's noticeable, which is weird because this is just Zoom doing the share screen. But I think it's just because it's coming from Jay's. But Jay, you have a big old pipe to your house, don't you? Like,
I have gigabit bidirectional fiber.
yeah. So it shouldn't be that it's coming from your house that's the problem. But I did notice it. I noticed Jay would say, "Oh, see that," and I wouldn't see it, and then it'd be like a beat, and then I would, which I don't notice with any desk.
I didn't have that experience.
There is a setting that I can tweak here, so I'm going to click on these 4 while I call it out. So we got 1, 2, 3, 4.
Yeah, that's insane.
I feel think now. So maybe it's just temporary.
It could have been just temporary.
If I choose this
Everything
setting.
just got blurry.
1, 2, 3, 4.
Now
The resolution has really dropped.
and I just got to 4. that was like a
That's
noticeable change.
I think that setting gives you higher frame rates and lower resolution, but for text we want high
Yeah.
resolution.
Yeah.
Maybe not
Actually,
higher frame rates. Maybe more towards the voice. That setting might preference your voice is being preferenced to your video.
It's called Optimize Share for Full Screen Video Clip.
Yeah, which is probably they care more about the voice than they care about the video. But I'm not sure. Either way, when you did it, there was noticeable lag. It got blurry, and the 4 didn't show up for like 2 or 3 seconds after you said it. It's still blurry, by the way.
I don't know if the setting is back. So.
All right. Okay, so it was weird that Chocolatey failed. I haven't really experienced that before. And it ran the next time, which makes me feel like it's just Murphy's Law in action. But all of that was interesting to say that, like, just the fact that we had established a pattern and we broke the pattern caused that impact. And it seems like it's such a low impact. Like, we go every 2 weeks, and now we did every 1 week. But because, so like for the rest of you, every 2 weeks we get together and we mob. But on the off weeks, me and Jay also get together and we just chat and like do some random programming and stuff. And so we thought this was just a chat day when we both logged into Zoom this morning. And so it's just weird that, like, on a more meta point, if you have an established pattern and then you break it, even if it's a trivial break, you're really introducing the chance that an error will occur. Right? Which is, I guess, like the benefit of an established pattern is you're reducing the chance that an error will occur as long as you're in the pattern. But you're increasing the chance that an error will occur when you're outside of the pattern. The thing you did at the beginning to give like a higher level concept, I believe the desire you have for that is bang on. And I believe your implementation of it did not work. I don't actually think your implementation of it should be in code. I think we need like a flow charty kind of high level, this is what we're going to try to do. That is completely missing. Right?
There's this basic idea of, like, what if you take a code construct, like a statement in this case, and turn it into an object that has the same meaning as that original code construct? And that idea, some people have seen and some people haven't. And I think if you haven't seen it, it's hard to wrap your head around the first time.
It's hard for me to
now,
understand.
actually, that is about the same thing I'm about to try to raise too, because with the experience of using Gradle as a task orchestrations, so basically what we're doing there is we give people a domain language to work with, and the pipeline versus task, at the moment it seems to me that really the task is a little bit easier to reason and talk with. But I don't know what is the domain we're going to settle with, but based on the experience dealing with Gradle, it would be much easier if we have a domain for people to work with, and then we gradually evolve that domain for people.
Task versus what?
Task versus pipeline. Or something else. Or function. Because really, task, function, pipeline are very similar terms.
Yeah.
At the end of the day, we want them to get executed, and we want them to be ordered.
Gradle is an interesting example to bring up because one of the places programmers deal with the pipeline style concept is in build systems.
Yeah.
Where we describe there are steps in the system, here's how they can possibly relate to each other, and you can write all of that, but everything that you write doesn't actually deal with it. It just sets up everything, and then at the end you say go. And that idea, that separation.
Yeah, and then you also need to parallel them.
Yeah.
And the people hate Maven and Ant because it's just so clumsy, and it's just so difficult to specify all of those relationships. And what Gradle has done really well is they give people a domain to work with. and task orchestration between those tasks.
Yeah. No, and like pipelines is really good for this concept. We are using it differently, but like pipelines is pipelines. But my point is, I think we should play with like an image or a mini slide deck that does what you are trying to do. I think there's two parts of it. One is just the general concept of moving from executing a line of code to encapsulating the execution of a line of code. Like, I think that concept needs it. But then the other thing that we didn't really touch on at all is what is the process we're about to walk through, right? Like, we're about to take some code, encapsulate each part line by line, see the result of it with this sort of shim in the middle, then pull it out so that the creation is in its own piece and we can test it, and then we're going to move the entire thing to be parallel. Like, that piece is missing.
Yeah, because even with Gradle, they acknowledge the fact that people need to visualizing the task graph.
Yeah.
It's the same thing here, which we already have. So we would definitely need to continue visualizing this task graph for people, which become very, very helpful as far as I can tell.
The other thing is our tutorial needs work.
Yeah.
One of the things that Claire and I were doing when we were creating the slides, there's like two parts of this that I think are interesting or relevant. One is we just made a whole bunch of namespaces. So like namespace example 1, and then we throw code in there, namespace example 2. And that allowed us to grab Markdown from like the steps of the refactoring that we're doing. Does that make sense? So we could just make like an examples or a tutorial where we put the code snippets in and have like step 1, step 2, step 3 as a namespace, and then duplicate the code that way. And then you don't have to worry about like names and stuff. And anyhow, that has been really useful for us. The other thing that I think is interesting is I've been playing with Markdown snippets into PowerPoint slides. So I really like Markdown snippets, and I'd like a way to get it into my PowerPoint slides. Because getting code into PowerPoint is it's annoying to get it in, and it's super annoying to maintain it. Right? Like, that is something that doesn't happen often. So it's very often that you have a PowerPoint slide with code that is wrong or buggy or doesn't actually compile or work.
Oh, yeah.
You found a solution for that?
I have an idea of a solution. So there's a thing called Markdown Templates that we use to write the documentation. And that works really well. Can you pull that up for a second? Just in our code. Like on GitHub. So if we go to those join calls. So we don't use Markdown snippets in this one. Yeah, we probably should.
Yeah. So this code right here.
Yeah. That's actual code, and you can actually see there it says like snippet source. If you click on it, you'll notice in the snippet source, it actually has this comment, begin snippet, end snippet. And then if we go to the Markdown above it, so go back to the Markdown, and then go up to the directory level, and then go into the, And so the code that we actually write to do this looks like this, and you'll see this like snippet, and we just sort of say what the name is. And so I want to take advantage of what Markdown Snippets does already to plug in a PowerPoint modifier. Now with PowerPoint you need a slightly different technique, and the idea would be you'd put in a text block this snippet thing. PowerPoint would find it, replace that text box with the code, and then at the very end a very small sort of transparency piece of text that says snippet this, so that it can rerun and redo it. But I think that would work. And I've done PowerPoint manipulation for the Sparrow decks. I think a similar technique would work to do it in the PowerPoint. Anyhow, the point being that I'd love to be able to have maintainable code snippets in PowerPoint, and so far that solution does not exist, and so I might have to invent it.
Nice.
But and then a larger context is I still really think that thing you were desiring is completely missing. Like we need something that shows the overall process to this, and I think that's missing in pipelines, period. So then we started out, and there was a lot of confusion on where we were going or what the steps are. That process, that pattern of take the line, put it here, move the pipe, like that doesn't seem to be in our documentation, and I kind of thought it was. So then they started doing it.
So when I started my first navigation journey, we went through the tutorial. I had no idea what those steps in the tutorial were about. So
yeah,
my navigation was and please do step one, but I had no clue what it even about.
That is that's why this is helpful for us. It's really hard to see what we don't understand.
I think the doc for this needs to be very specific and needs to exactly match the code that it's operating on. And right now it's more like, here are the kinds of things you should do, go figure it out. I think we need to spell out those details.
Agreed. Other things observed. So the pipeline diff image reporter would have been just helpful. I feel like when we're doing this, we don't really care about the viz graph. We really just care about the image. So it would be really nice to have that as a reporter. That refactoring template. So if we just did the extract local variable, I bet we could make a macro that would just convert a local function to a lambda. But also, it makes me really want to write a plugin for like, what I really want to do, although I'm not sure I can do this, is pair with someone at IntelliJ or at Resharper for what has to be less than 2 hours and write this refactoring.
Wait till you see how poorly factored their code is.
It could be.
Guessing.
I feel like that, because introduce lambda is something that's just so useful, and I don't understand why it's so hard to bring in. I don't understand why var doesn't work for a lambda function.
Because lambdas can be either funcs or expressions.
Yeah, but can't you tell by what the code does? Like,
No,
if it returns, var means it's a function. Right? I don't understand why it's not. But anyhow, it feels like introduce lambda is something that would be an easy thing to do. And it'd be nice to actually write that as an extension point or pair with someone to get it just into the core thing. Our tutorial doesn't link back to our actual page, and our page isn't linked to, like, there's some links that are missing there. And just go just that from notes that are sitting in front of me. The part where we started extracting this to the test, I feel like that was completely follow the leader style. Like up until that point, the tutorial was sort of guiding them, right? Like it was doing it poorly. But after the point where they had made the pipeline, extracting it, moving it to the test, I feel like that's not even, there's no chance if we weren't here telling them what the next steps were. And so I feel like that's a super big failing in what we did.
Well, we completely ignored the tutorial. There was no need for it.
Yeah, although I don't think it's in the tutorial. All right. Other observations. All right. That's probably a good place to call it a day.
What do you want me to do to collect all of this?
You can do file publish and then tweet it.
And download it as well as PDF and free mind.
Oh yes, thank you.
Where are they here? Title.
Just
Sorry
say
guys, I
publish.
think I have to run now.
No worries. Thanks for joining
Sorry
us.
guys.
We'll see you in 2
Yeah,
weeks.
thank you.
Somebody else?
Yeah, see you.
See you in 2 weeks.
Yeah, see you in 2 weeks. Thanks guys.
Thanks again for today.
Absolutely.
Yeah, thanks.
Bye.
Bye. Thanks.
So just say publish for 6 months, Jay. I'm gonna turn.